Okay, all right. Let's take a look and begin. Happy Friday, everybody. This one, I think if you do git pull, it'll download a bunch of files. Okay? Yeah. So this is where GitHub is really nice, because rather than having to download everything separately, just one command pulls multiple files. Okay, so today we will talk about working with files. Okay, so let me clear some of this. And I apologize, some of the, I'll talk about formatting some strings here. And I was like, oh, you know what? Probably should have covered this a little earlier. But you guys also, you know what? An important thing you've got to learn in this class, and anytime you do programming language, just stuff in general, one thing, a very useful skill that really you have to learn by doing yourself, and I can't just show you stuff in class, is learning how to read documentation and figuring out how to use something new that you've never seen before based on documentation. You probably had to do a little bit of that, which is good. Okay. So here we're going to talk about working with files and really just kind of like saving your output from Python somewhere, because most of the time you run a script and it produces the output and poof, it's done and it's gone. Jupyter notebooks will kind of preserve the console output, but every time you kind of load up a Jupyter notebook again, all of those values that were created, they're no longer in memory. You just kind of have the traces of what was output onto the screen, and that's stored in the notebook itself, but the values, those aren't there. Okay, so if you want to store values and output and things like that, you have to save them somewhere, and the simplest is to save things to a text file. So we'll start there as kind of our starting point. Okay. So in order to do this, you have to open a connection. Okay, open a connection to an output, and so we're going to use this base function in base Python called open. And when you call open, you give it the name of a file that you want to write to. And so here we're just going to write to a text file that we're going to call output.txt. If the file already exists, it will replace the file. So don't give it the name of something very important, okay? And this is where having git is also useful, because you can roll things back if you accidentally messed something up. So anyway, we'll do output.txt, and then we're going to say the mode that we want to connect with is write mode, okay? That's going to be write mode. And so we'll call this object, this connection, fout, our file out, okay? And here I'm going to just write, create a string. Line 1 is going to say this is the first line of text, and we're going to write that line to fout.write line 1. And so what we can see is that if I take a look and I type in git status, we can see that, okay, well, it's got all the other things that I've changed. But we can see output.txt has been modified. And I might even be able to open output.txt in Jupyter. Okay, right now, okay, we haven't closed the file, so it hasn't, all we see is that it's just kind of been flushed here, okay? We're going to write another line, so I'm just writing, this will be the second line of text, okay? So we do fout.write, and again, so far, nothing, if I kind of open it right now, it hasn't shown kind of the changes, but I'm going to go ahead and close the connection. When you close the connection, that's when it will save all of those changes. So kind of these changes, I guess, exist kind of in memory, and then so now when I close the file, output.txt now contains the output of what we've written. Okay. So yeah, closing the file frees up the system resources dedicated to tracking that file, and that's what it will do. Okay. Yeah, if you don't close the file and Python sees no names bound to that kind of file object or whatever, Python's garbage collector will kind of automatically close the connection eventually. I don't know. Not 100% sure. Okay. You can also do other things. So you can write with open. So you can write this, and here it will do that. And here I'll just do one more. I'll do file.write a third line. Okay. And so here when you do with, okay, what this will do is it will run all of these things, and then when it's done, it will close the connection. Okay, so I'll do that, and then now if I open up output.txt, we can see indeed it got those commands got written. Okay, and then the other way you can do it is you can read mode. So when you open a connection, another mode that you can do is read mode, which is R, and that's going to give us, it will kind of read in that file line by line. Okay, so we see the first line, the next line, and then any other lines that you have there. As always, you can always ask for help. And so regarding open, it tells you the different modes and in the documentation. So you have reading, you have writing. You can say create a new file and open it for writing, which I think, let's see, binary mode, text mode, I don't know. Open for writing, append to the end of the file if it exists. Okay, so here, I just want to try playing around with this. Let's copy this, move down here. So I'm going to try append mode, and I'm going to just say file write, let's append a line, and let's run that, and let's kind of take a look. Oh, okay, it did append the line, but I didn't put in a new line, so it just added straight to the end there. Okay, but yeah, that's it. That's it did exactly what I asked it to do. We'll say that. Right. That's one thing to keep in mind. So I guess what I would want to do here is I would do file.write/n. Okay, and so now let's append a line there. And now if I open this, okay, so there it's adding it there. Okay. So that's the thing about computer programs. You're like, why isn't it doing what I want it to do? And well, it's doing exactly what you told it to do. It's just okay. Here is we have the format operator. This allows us to kind of format text strings. So we've seen some of this stuff. So one way to kind of convert strings or non-strings into strings is with this this function str. Okay, so if I just had this float 42.3 and I wanted to say 42.3 is my favorite number, it's not, but I don't know. Do you guys have a favorite number? Because if I do the plus operator, it's going to say you can't do a plus between a float and a string. Okay, so we get a type error, unsupported operand for plus, float, and string. But here we can say we're going to convert the 42.3 into a string, and then now we can do that. 42.3 is my favorite number. Okay. Another way for us is to take the string, okay, and within the string we put in curly braces, okay, and then we use the dot format method there. Okay. So anytime Python sees curly braces, it sees those as kind of replacement fields or placeholders for stuff. And there's more information about this on the format specification mini language. So here I'm going to just kind of put curly braces is my favorite number, and then we're going to do dot format, and we're going to put in that value 12.34 in there. Okay, and we get 12.34, my favorite number here. I've got two numbers. X is 12.34 and x2 is 37.8. And I now have two placeholders. Blank is my favorite number and blank is my second favorite number. And then you can kind of put in dot format and put in multiple things sequentially, and it will do it as we would expect. So 12.34 is my favorite and 37.8 is my second favorite. If you wanted to, you can also put in little numbers here, okay? And it'll index them, okay? So it'll put so when you give dot format, it'll kind of read these in as a tuple, and using the index in that tuple, it will fill this in. So here I've got curly brace 1 is my favorite number, and curly brace 0 is my second favorite number. Again, my favorite number is curly brace 1. And so here we're going to have format x and x2. So x2 is going to have index 1. So it's going to say 37.8 is my favorite number, and 12.34, again, my favorite number is 37.8. And it works exactly as we asked. Okay. If you have, you can also do give it the index. So here we're going to say index 0, and then you can put in a colon, and after the colon you can give it additional specifications on exactly how should it format that value. So here, just to kind of illustrate what happens, okay, here I have x is 0.0001234567889. x2 is 0.0001234567889. So index 0, we're going to just leave it as generic G, and then we're going to say I also like dot 8G, okay, 1 colon dot 8G, and we will put in x and x2, and so you can see for this it keeps 6 significant figures, okay, or and it 1 2 3 4 5 6 7 8 I guess 9 places after the decimal, 6 significant figures, and so it was 1 2 3 4 5 6 7. That 6 gets rounded to a 7 here. Over here I said keep 8 significant figures, and it's going to print it out in a scientific form, and we get 1.23456 and then that 8 9, that 8 got rounded to a 9, and it says E minus 05. Okay, so that's what we get. Okay, if you have an F, okay, F is fixed point format. Okay, default is fixed points after the decimal. So that's going to be what? 0.000123, and it will just kind of drop the 4 5 6 7 8 9. Here I'm going to do dot 8F. 8F will be 8 places after the decimal, and I think that's going to be 1 2 3 4. It will also end at 1 2 3 4. Yeah. Okay. And then because of the rounding, that 1 2 3 4 5, that 4 gets rounded up to a 5. So that's fixed point format. So that's useful for like money, and you don't want to see fractions of pennies on your receipts and stuff, even if that's what's happening when you do, because if your tax ends up something, nobody gets angry over the fractional penny. Does it round properly? I don't know. I've never bothered to think. I don't know. Okay. Okay. The plus operator. Okay, so again, if you didn't want to use the placeholders, you can always kind of do this plus, and then you just kind of take these things and turn them into strings, and we get that. The indices for placeholders are optional, so you don't have to put anything before the colon, and you can just leave them as such. And so here I've got my name is curly brace S. I am curly brace G, years old, and curly brace is my favorite number. And then I'm in the tuple, I'm going to put in Joe Bruin, 183. Actually, how old is Joe Bruin? UCLA 1919? Is that our founding year? So 105 then? Is that right? I don't know. Or was Joe Bruin a later creation? I don't know. Somebody look this up. It's an emergency. Okay. Let me give you the first view quiz answer. Capital, there's no capital. The letter C. The letter C. First view quiz answer is the letter C. Okay. Capital C. There you go. C for capital. That was when he was created, 1926?
Yeah.
Oh.
That's when the Bruin became.
That's when he became the mascot. Did he always have the name Joe?
Oh, I should look that up.
I don't know. That's his name, right? Or is it Joseph?
There's
Joseph Bruin.
Is his name Joseph Bruin?
Oh, he's young. He
Jo-
became the official mascot in 1963.
Official mascot 1963?
Yeah.
Oh, okay.
He's not,
Well, he's a boomer then. Okay. Joseph Bruin? Josiah? I don't know. Joe Bruin. Okay. Important questions. All right. What is a Bruin anyway? I mean, it's a bear, but I've never heard of that term outside of UCLA.
It's like a mythical thing.
Is it a mythical thing?
Yeah, that's what they refer to in like fairy tales.
Fairy tale bears are known as Bruins? So like Goldilocks and the three Bruins? Okay. We have 0, 1, 2. Here I'm going to just put in A, B, and C. These are just straight from the Python documentation. So here, puts it in with the commas. If you don't do anything, it puts them in just kind of the order that you expect. 2, 1, 0 will get what? CBA. 2, 1, 0. And then look at this. This is always a fun little thing that you can do because it treats strings as iterables, and so you can explode them, or not explode them, scatter them with star. Okay, so so you can do that, and this is what we have. This is always kind of, I always had fun with like oh, what just happened here? So can we do like what is the thing that I would need to do? Dot format she and cells and C and shore, and what is this? So we're going to need to do 0, 1, 2, 1. I have to do by the 3. No, 2, 3. 2, 3. Is that right? She sells seashells by the seashore, something like that. Okay, I don't know. Come up with something fun here. Peter and Piper. Now that's not that good. Okay, but anyway, you don't. You can also put in names rather than just indices. Okay, so if you wanted to do like latitude and longitude, so it's easier to understand this later, you can do that just as easily. You can also create a dictionary, right? You can create a dictionary and then push that into dot format. And then in this case, if you wanted to unpack or scatter the dictionary in order to have the keyword pairs, you would do 2 stars, okay? And then it'll have the key, and it will replace it with the value. Okay, so that's kind of nice. All right, and then you have these things like the less than 30 or whatever, and this will specify how the length that it needs to be, okay? And so you can have left aligned, right aligned, and centered if you're gonna like fill out some kind of text file with text there. All right, but that's that. Okay. All right, other stuff. Sometimes you want to kind of like work with the files that you have on your computer, and you can do a bunch of stuff with Python using the OS module. Now, sometimes your computer security settings, anytime it sees OS, it might freak out a tiny bit and be like, "Are you sure? Are you sure you want to let Python mess with your the files and stuff?" You probably signed away your rights when you not signed away your rights, but just like when you installed it and you had to put in the password in the first place, it probably said, "Oh, okay, we'll go ahead and let it do that." But just be careful, right? So yeah, don't. Sometimes you're like, "Oh, I'm stuck," and you go on some random website and it's like, "Hey, what code should I run?" Okay. Anytime you see OS in that code, be very careful, because you can potentially, like, if you just blindly copy someone's script, that's dangerous stuff. Okay, so don't always read someone else's script before you run it on your computer here. All right, well, anyway, you can get your current working directory. So I'm in my 2024 SP Stats 21 folder, and whatever you want, right? You can also, so this is going to give us your thing. You can also ask, what is the absolute path that corresponds to the text file output.txt, and this is the output path. Because I'm on a Windows machine, it's got a double escape, the backslash is. Normally, probably on your Mac OS machines, you'll get the /, but that's what we have. Okay, you can check to see if a thing exists. So does the file memo.txt exist? That does not. Does output.txt exist? It does. Is this thing a directory? It is not. Okay. What about .git? That's in my folder. That is a directory, right? So you do path.is directory and things like that. Again, a whole bunch of these OS functions are in this. You can read the documentation about all of the different stuff. And there's a lot of stuff, okay, that I don't even know what they do. You can also list what's in your directory, all right? And so right now I have basically all of my lectures in there, and that's that. I guess these are some of these things are miscellaneous topics here, but one of these things that we have is try and accept. Okay, try and accept is kind of like if and else, except what you do is in the try you put in the stuff that you want to do, and then you put in a corresponding accept, which means if it encounters an error, don't just quit the program, but then go do something else, okay? So here, if you just tried to run some kind of command that results in an error, so here I say open bad file doesn't exist, it just gives you the error and then it would kind of halt your code, okay? Oh, I do want to point something out. On Jupyter, you can have, if you intentionally want your codes to return an error, you can flag it, okay? And so under view, you can do, wait. I want to see the, property inspector, okay? Property inspector, and over here, under property inspector, in the cell, under common tools, cell tags, you can put in a tag that says raises-exception, okay? And if you have raises exception there, because normally if you don't have raises exception, when if I did like kernel restart kernel and run all cells, if you don't have raises exception, it's going to encounter the error, and then it's going to halt, right? So it encounters the error, and then it just halts. But if you put in raises exception, raises kernel, and run all cells, then it encounters the error, and it says, oh yeah, that was expected because, oh yeah, right. Oh, here, okay, I gotta put it on that one. So anyway, it encounters the error, and it says, that was expected, so we're gonna keep going, okay? So where did it go? So here it encounters the error, but it keeps going. So you can add under in Python, you view the property inspector, and under with the cell that you want, you can put in a tag raises exception. Okay, how do I hide this now? Okay, so we want that to go away. All right, so you can do, instead of having it throw an error, you can also do try except. You put in, if the command goes wrong, you put in except, and then it will run whatever's in the except block. In this case, it was something went wrong. And it doesn't throw an error because you caught it, okay? Clear all outputs of cells. Sorry, let me get it up to here. Run up to selected cell. There's a question?
Yeah, I don't see a property inspector when I go to
Under view, you don't have properties inspector? Does that not appear? Do you have a little gearbox in the top right corner?
yeah.
You can click that, and that should also bring up the properties inspector. Okay, and then under cell tags, you just, if raises exception isn't there, you just type it in raises dash exception, and that will do that. Okay. We have something called DBMs. Okay, DBMs are little Python databases. They operate very similar to a dictionary, except they're going to get stored as a file on your hard drive. Okay, so we're going to create a DBM called captions. All right. So first you have to import the DBM module or library here, and then you're going to open a connection. Okay, with a DBM file. And so we're going to just create a file called captions, and C is going to create it rather than overwrite an existing file. Okay, and we'll go ahead and run that. And so that's why we have these files called captions.dat and captions.backup and captions.dir. Okay, and so we have captions, and then here our key is going to be cleese.png, and then the entry or the value will be photo of John Cleese. So again, I'm copying examples from ThinkPython, and the author of ThinkPython is a big fan of Monty Python, okay, which I guess he thought, well, this is great. And so anyway, we have this. Cleese, so that's going to create basically an entry in our DBM, and it works very similar to a dictionary. You can retrieve things from this DB, okay, or DBM, and you just kind of give it the key, and it pulls it back. All right, we're going to add another thing. We get we're going to put in Jones there, and then we'll iterate through the database. So for each kind of key in the DBM, we can say print out the key and the thing. Oh, I guess, okay, we haven't created this list yet, but I created, it's, that's coming later. So sorry, that's this list that appears here is a result of something that I run later, but because it got stored and committed, that's why it's appearing here. So sorry, that's a little bit confusing there. Okay, and of course, just like anything else, you should close it. And so we'll close the DBM file. when you do this and you can say, hey, what are the files that it created? It's going to create, generally it's going to create the data file along with a backup file and I don't know, a .dir file, okay? One limitation of these DBMs is that it can only store strings or bytes. And if you want to create something else, like a list or something, you have to, this is kind of a little bit funny, you have to pickle them in Python, okay? So pickling is basically preparing something for storage, right? So it's kind of like, I guess the idea is if you just take a cucumber and you just put it away in your pantry, it's going to rot and it's not going to work, right? But if you want to store it, you can, I don't know, do a pickling process, and then it doesn't have to be refrigerated. You can just put it in your pantry and it'll be okay. So it's the idea of kind of preparing any of these Python objects for proper storage. So here I'm going to create a list T with the values 1, 2, 3, and here we're going to try to store this into the captions DBM file. So we're going to say dbm.open captions C, and again this is kind of just don't overwrite anything that's in there, okay? And here I'm going to try to save that list into the DBM. And if I say, hey, db list equals T, I get an error, right? It says values must be bytes or strings. So so we'll do this, and we will pickle this, okay? And so with pickle, and you can read more about Python pickle. What's warning? The pickle module is not secure. Okay, yes, it is not. But pretty much the functions that we have are dump and dump s. Okay, dump s converts it to a string, versus dump creates I think creates a byte object. Pickled representation of the object. Dump s is pickled representation of the object as a bytes object instead of just writing it to a file. Okay, well, that's the difference here. So here we're going to take our list T, right? T right now is just this list 1, 2, 3, and we're going to do pickle.dump.st, and this will convert this into basically a byte string representation. This is not meant to be read by humans, okay? Whatever this is, the computer understands is the pickled representation of this list 1, 2, 3. So now that we have this, I'm going to do db list equals s. And this is allowed, okay? So trying to just store the list directly into the db gives that. Okay, so now I'm going to close that. And then, all right, so we'll pretend we've done stuff, and now we can open it. I can retrieve this thing, all right? And if I want to turn this back into something that I can use, all right, so again, this is not readable. I would call load s. So we have dump s and load s, and then we have dump and load, okay? So the opposite of dump s is load s, and the opposite of dump would be load. So we're going to take db list, and we'll call load s, pickle.load s on it, and that converts it back into an object that we can work with. So it's a little bit of an extra process, but it allows you to kind of take these different objects, pickle them, put them into the db, and then retrieve them, and then I guess unpickle them. I don't know what the you can reverse this process and get back the original file. So yeah, unfortunately it's not an automatic thing. You have to kind of do this explicitly. All right, you can pickle objects directly to a pickle file using .dump, okay? So rather than putting them into, say, a DBM, okay, which stores strings and bytes, you can put them directly into a pickle file. So here, object 1 is going to be a list. Object 0 is a list of strings. Object 1 is a list of integers, and object 2 is just a string here. And I can say, hey, let's create this thing, objects.pickle. Okay, WB is going to be write in binary mode. All right, and we're going to open that, and then we're going to call pickle.dump, and then we will put in the 3 objects that we want to do. Okay, we'll group them together into a list or a tuple, and then I'll say dump them into that file. Okay, and because we use with, this will open the connection, and then once it's done running the code, it closes the connection, right? Okay, so this is objects.pickle. If I try to just open it, it says, yeah, you can't just open it straight up, okay? But here I can kind of open this. Here, let me just show you what, if I just call open this, in read, we'll just get, it'll say, hey, this is what you write in. But what you can do is you can do pickle.load, and we'll do that. And so this, when you load it, it returns back basically the list of objects that you have. And so now what we can do is we can open it, and I can unpack this, right? And so now that we have that, I can say, all right, here's object x1, here's object x2, and object x3, right? So these are the things you can do with pickles, okay? And then again, more documentation on as far as what can be pickled and unpickled, and pretty much a lot of stuff. I'm trying to think, what can't be pickled? This is what can't be pickled in Python. I don't know. Stack Overflow, what do you have to say? Okay, no, that's not gonna help me. Oh, let's ask the chat. Unpickling, no. Okay, things about cannot be pickled. Okay, classes, functions, and methods. Wait a second. The following types can be pickled: functions and classes. What are you talking about? See, these cannot be pickled. Huh? Who do I trust here? I don't trust you. All right, well, okay. The following types can be pickled: functions. So, pickling class, and he's pickling a class right there. All right, so you are not telling me the truth, being chat AI. Okay. Well, anyway, all right. That's about it. Okay. How many answers? I gave you 1. All right. I guess, you know what? We will be generous. We'll give all 3 in the video. I know. Oh, you guys came to class for no reason. You just, you could have gotten all 3 answers in the video today. But it's Friday. Well, no, it's just, I'm just in a good mood. Okay. Second answer is B, and third answer is E. Second answer is B, third answer is E. All right, have a great weekend. Some of you I'll see at Data Fest. And other than that, we'll see you all Monday.